If I give you a problem where we have two objects, object 1 traveling to the right and object 2 traveling to the left, and they collide, and let's say they stick together after the collision takes place, we know how to deal with this. We say Pi is equal to Pf. We would say M1 V1I plus M2 V2I equals M times Vf. This final mass being the mass of both of them combined, if they stick together. All right, this isn't rocket science. We've done this a million times before, and I think we're pretty good at it by now. If I give you this problem, where we've got object number 1 traveling downwards and object number 2 traveling upwards, we would do exactly the same thing. Pi is equal to Pf. Let's assume they stick together again. M1 V1I plus M2 V2I equals MVF. Again, not rocket science. We've done this before, and we've gotten pretty good at it over the last week or so. What if I give you a problem like this, though? What if I give you a problem in which object number 1 is traveling to the right, and object number 2 is traveling upwards? So it's kind of a combination of the first problem and the second problem. Let's say these two objects stick together in this collision. Where's the wreckage going to go, first of all? It's going to go up and to the right. It's going to go up here somewhere, right? Where exactly? We're not sure. We know it's going to go northeast somewhere. The exact angle, we don't know until we figure that out. How are we going to analyze this problem? Well, if you pretend object 2 is not there, then the problem basically becomes something like problem 1. If you pretend object 1 isn't there, then the problem becomes basically something like problem 2. So what we're going to do to analyze this problem in green here, this two-dimensional or non-collinear interaction, is to break it up into two problems, two separate problems. Then we're going to analyze the two separate problems, then recombine them at the end. The first problem will be our x component. For our x component, we will say Pi is equal to Pf. We will say M1 V1I plus M2 V2I equals MVF. Then we're going to analyze our y component. Once again, we're going to say Pi is equal to Pf. M1 V1I plus M2 V2I equals MVF. See how so far this problem in green is really like the two problems in blue, just combined? In other words, a two-dimensional collision is really just two one-dimensional collisions that we have to combine together. Let's say the velocity of both of them is 10 meters per second. Tell me what V1I is right here. What's V1I right there for the x component? 10. Tell me what V2I is for the x component. 0. Good, Micah. Thank you. Why is it 0, Micah? Yeah, we're analyzing only the x component right now. As we analyze only the x component, we look at object number 1, it's moving in the x direction. Object number 2, it's not moving in the x direction at all. So as far as x is concerned, it's not moving. We're going to say V2I is equal to 0. Let's go to the y component. What's V1I for the y component? V1I is not 10. V1I is 0. Because object number 1 is only moving on the x-axis, not on the y-axis. What's V2I? 10 meters per second, because it's moving on the y-axis. Does that make sense? Let's say we're solving for VF. Let's say we're solving for this, VF. Once we get this and this, the x component and the y component for VF, what do you think we're going to do with that? We're going to add the vectors. Yeah, we're going to go back to physics 20 stuff now, right? We're going to draw a vector diagram, a right-angled vector diagram. Then we're going to do the Pythagorean theorem. And we're going to do the inverse tan function to add those vectors together. All right, let me put up a couple notes here for you, and then we'll do an example problem, okay? When analyzing a collision or explosion, should say or explosion, not of. When analyzing a collision or an explosion in 2 dimensions, we're going to break that problem into 2 separate problems. The 2 separate problems that we just did, the x problem and the y problem. Then we're going to recombine them. And as Micah said, we're going to recombine them by drawing a vector diagram, doing the Pythagorean theorem and the tan function. When we're analyzing the x part of the problem, then we're going to ignore everything that's y. So anything on the y direction, when we're analyzing x, we say is 0. Similarly, when we're analyzing the y component, anything that happens to be on the x-axis, we say is 0. Let's look at one part of the problem at a time, and then let's worry about putting them together. This really isn't any harder than the problems that we've done up until this point. It's just more work. It's not harder, it's just more of it. What are we doing again? Once we analyze the x component and the y component, as Micah said just a few minutes ago, we're going to recombine them by drawing a right-angled vector diagram. And then we're going to use the Pythagorean theorem and a little bit of trigonometry. That trigonometry that we're usually going to use is probably going to be the tan function. Although the other trig functions are also valid because you've got a right-angled triangle. All right, let's do one example with this, okay? 90-kilogram quarterback moving at 7 meters per second at 270 degrees. That notation doesn't make a lot of sense to us. So I'm going to draw that up for you here. If it's moving at 270 degrees, it's moving downward. It's tackled by a 110-kilogram linebacker traveling at 8 meters per second at 0 degrees. If it's 0 degrees, it's traveling to the right. You don't really need to know that. I'm telling you what the 270 and the 0 degrees means. What's going to be the velocity of the center of mass of the combination of the 2 players immediately after the impact? So these 2 players aren't sticking together, but since we're finding the velocity of the center of mass, we're effectively assuming they do stick together. One guy goes off one way, one guy goes off another way, but in the end, their center of mass goes off in the direction that they would both go if they stuck together. So what is the velocity of their center of mass? Best way to do this is to draw a picture. We've got object number 2 traveling to the right at 8 meters per second, and his mass is 110 kilograms. We've got object number 1 traveling downwards. His mass is 90 kilograms, and his velocity is 7.0 meters per second. Where do you think the center of mass of these 2 football players is going to go immediately after this collision takes place? Pardon me? Where's it going to go? Where's the center of mass going to go? It's going to go east and south somewhere. Exactly where, we're not sure, but it's going to go somewhere down in that range, right? If you've got a momentum that's to the right, there's got to be momentum to the right after the collision as well. If you've got a downward momentum before, there's got to be a downward momentum after. Let's break it up into x's and y's here now. We're going to say pi is equal to pf. We're going to say m1 v1i plus m2 v2i equals mvf. M1 is 90 kilograms. What's v1i? Rob, what's v1i? v1i for the x component. v1i for the x component. That's v2. That's object number 2.
7.
No, not 7, but you're getting closer. 0, right? Why is it 0? How much of that 7 meters per second is on the x-axis? None of it, right? So we're going to say that v1i is equal to 0. Does that make sense? Okay, m2 is 110 kilograms. v2i is going to be 8 meters per second because all of that 8 is on the x-axis. The combined mass here is going to be 200 times vf. 110 times 8 is going to be 880. 880 divided by 20, or by 200, is going to give me 4.4. So VF is 4.4 meters per second. Have I just got my answer? Am I done? What have I just solved for? This. Right? I've solved for the x component of my final answer. It's not what I want. Let's do the y component now. Let's say for the y component, once again, pi is equal to pf. Let's say M1 V1I plus M2 V2I equals MVF. M1 is 90 kilograms. What's V1I this time? It's not 0 anymore, is it? What's V1I? How much of that is on the y-axis? How much of that 7 is up or down? All of it. So we're going to say 90 times 7. How about 90 times negative 7? Good, Nick. 90 times negative 7. Why negative 7, Nick?
Because it's going down.
Good.
I was just wondering, why is that 1/2?
Why isn't it 1/2 MV? Because you're mixing up kinetic energy and momentum again, right? We're back to momentum here now, where we're analyzing it as a collision. Find the final speed using conservation of momentum. Right? The 200, that's a good question. Where does 200 come from? If they stick together, and that's what we're assuming that they do because we're looking for the center of mass velocity, then the final mass of the combined wreckage, for lack of a better term, of these football players is going to be 110 plus 90. Yeah, it's the combined mass. Good. What's V2I? Rob, what's V2I? 0. Good. Because we're dealing with the y component now, right? So none of this is on the y-axis. The combined mass is, again, 200 times VF. Solve for VF here. 90 times negative 7 is 630. Divided by 200, I think, gives you 3.15. Or negative 3.15. That's not my final answer either. That's this. You want to find this, and you want to find this. Let's do the Pythagorean theorem. 4.4 squared plus 3.15 squared. Let's find the angle by using the inverse tan function of opposite over adjacent. This is all physics 20 now, right? You didn't do it with momentum in physics 20, but you did it with displacement, and you did it with force. Exactly the same mathematics. 3.15 over 4.4. What do we end up getting for the speed there? 5.4 meters per second, and the angle would be 35.5, so 36 degrees. Yeah, it'd be 36 degrees below the x-axis, yes. Does that make sense? All right. Class is going to be over in just a couple minutes here, so we're not going to assign any questions to go along with this. We'll pick this up either tomorrow or on Friday, depending upon when we can. Just kind of keep this in mind. Remember this over the next couple of days as we go and move into this with our practice problems that we're going to do likely on Friday. Okay. So what do we got coming up on Friday? We got a quiz on Friday, quiz number 5. It's on conservation of momentum and elastic/inelastic collisions. We also have, we also have check and reflect questions due on Friday as well, right? All right, that's it for us.